Hello everyone, my name is Marcela Polic and I come from the Laboratory for Robotics and Intelligent Control Systems from the University of Zagreb. Today, on behalf of my colleague Jelena Tabak and my supervisor, Assistant Professor Matko Orsak, I will present our work in progress in the field of agri-food manipulation. The work investigates the ability of a robotic harvesting solution developed for sweet peppers to be adapted to generalize to strawberries. The work we present here is done as a part of the Specularia project. The aim of the project is to enable a robot team to autonomously conduct various agrotechnical procedures in structured greenhouse cultivation. In comparison to the classical industrial environments, the working environments of robots in agriculture are more complex and dynamic. In this project, we focus on interaction of robot manipulators with fragile objects such as plants. Fruit picking is one of the most prominent applications of robots in agriculture. Most of the existing solutions are highly crop-specific and still encounter unresolved issues in fields of perception, motion planning, and dexterous manipulation. Here, we investigate the generalization ability of a robot harvesting solution. In particular, we investigate to which extent a solution developed for sweet peppers has to be adapted for deployment on a strawberry crop. For successful crop detection, localization, and grasping, we need a robust perception method. One of the challenges here are the changing lighting conditions. A line of research proposes controlled illumination methods. In our work, we rely on the structured cultivation environment, where strictly controlled workspace conditions are ensured for the manipulator. The setup is envisioned with plants carried to the manipulator station by a team of UGVs. Another issue in perception is generalization over plant physiognomy variation. Most early detection systems were based on color filtering and were bad at generalizing due to sensitivity of the fine-tuned machine vision methods. The advent of CNNs improved generalization immensely. This is the approach we have taken as well. Here, a new problem arises related to dataset generation. One possible solution could be in synthetic datasets. We are working on generation of automatically labeled synthetic datasets for strawberries using insights from pepper harvesting experiments. Examples of realistic renders of plant models are shown in the figures, where, for example, a more detailed plot with realistic texture can be seen since a smooth surface proved confusing in the pepper dataset. The sim-to-real results of this approach proved quite successful with the peppers, and we hope to achieve similar detection results using synthetic strawberry dataset, with fine-tuning on a small dataset of real images. Precise fruit pose for grasping can be obtained by combining the 2D image detection with depth information, for example by surface or volume model fitting. Our approach with peppers is based on cylinder fitting on the extracted pepper point cloud. However, for strawberries, this is still an open question in the ongoing work. Finally, we'll mention one of the important issues in the motion planning, which is obstacle avoidance for safe plant manipulation. The approach we've taken with peppers is based on approximation that reduces the probability of collision without specifically taking into consideration the particular plant parts. We plan to use a similar approach with strawberries, perhaps modeling the plant bounding volume with a different geometric primitive. More details can be found in our extended abstract submitted to this workshop. For any questions or suggestions, feel free to contact us via this email. The results of our pepper picking experiments can be found in the link. Thank you for your attention.